Have you ever stopped to think about what it really takes to keep a megacity like Delhi running? I mean, it's not just the roads or the power grid. There's this massive, hidden network of pipes, the city's veins and arteries, that are constantly working, delivering life-giving water and carrying away waste. Today, we're going to dive deep into the engineering mission that is managing Delhi's water. So, to really get this, I'm going to put you in the driver's seat, okay? Imagine you're an assistant director at the Delhi Development Authority, the DDA. Your job, your whole responsibility, is managing this critical circulatory system. And let me tell you, your mission has just become more urgent than ever before. Let's get into it.
All right, welcome to your first briefing. We're going to go over the huge challenges facing Delhi's water supply right now, and the major shift in strategy that you are now expected to lead.
Okay, so the situation on the ground is pretty critical. The city is facing a double whammy. First, we have a serious groundwater crisis. We're basically pulling water out from under the ground way faster than nature can put it back. And at the exact same time, there's this huge push to clean up and rejuvenate the Yamuna River. So the old way of doing things, just use water and then dump it, that's just not going to cut it anymore.
And this brings us to the absolute core of your new strategy. It's called circular water management. What we're talking about is a fundamental shift, right? We're moving away from that old linear system of take, use, and dispose. Instead, we're moving to a circular one, where we treat and reuse every single drop of water we possibly can. This isn't just a cool idea. This is the future.
So, let's see how this all actually plays out, starting with what we're calling the arteries. These are the systems that deliver fresh, clean water right into people's homes and buildings. In most DDA housing, the standard is the indirect system. It's pretty straightforward. Water gets stored in an underground tank, or a UGT. It's then pumped all the way up to an overhead tank, the OHT, and from there, gravity does all the work. Simple. But for our modern high-rises, that's not really efficient, so we use a hydropneumatic system. This thing uses pressurized tanks to give you constant, strong water pressure no matter what floor you're on, and you don't need a gigantic tank sitting on the roof.
All right, the water has reached the building. Now, let's go behind the scenes. Let's go inside the walls and take a look at the invisible infrastructure that makes all of our modern sanitation even possible.
So here's a question for you. Every single day, in pretty much every home, there is an incredibly simple but absolutely vital device that stands guard, protecting you from the main sewer line. Any idea what it is? It's the trap. You know, that little U-shaped bend in the pipe right under your sink or in your floor drain. It's genius. It just holds a small amount of water, and that water creates a physical seal, blocking all the foul and potentially dangerous gases from the sewer from coming back up into your house. So simple, but absolutely brilliant.
And you know, precision is everything here. For that little water seal to actually work, it has to be at least 50 millimeters deep. That specific depth is the bare minimum. Any less than that, and it could just evaporate or get siphoned out, breaking the seal and failing at its one and only job.
And the trap isn't working alone, it's part of a whole team of pipes. You've got the soil pipe, which carries waste from toilets. The waste pipe, that handles what we call sullage, the gray water from kitchens and sinks. And then you have the vent pipe, which is kind of the unsung hero. It provides airflow that stops pressure changes from literally sucking that crucial water seal right out of the trap.
Okay, time for a quick field test. You're on site. Where would you install a gully trap? Is it A, between two sewer manholes, B, at the junction of a waste pipe and the external drain, or C, between the toilet and the soil pipe? Think about it. And if you said B, you are absolutely correct. It's the collection point where all the waste pipes from your kitchen and sinks meet up, and it provides that final protective seal.
So now that we've got the waste out of the building, let's follow it into the city's larger veins, that huge, vast network of sewage pipes designed to carry everything away safely. Now, this is a really critical design choice. A combined system, which mixes sewage and rainwater in the same pipe, well, that would be a complete disaster in Delhi. Can you imagine? During a heavy monsoon, the pipes would totally flood, causing raw sewage to overflow right into the streets. That's why the DDA standard, and the right choice, is a separate system. We keep rainwater and sewage in their own dedicated pipes.
But no matter how well designed the system is, every single city engineer faces the same relentless enemy: clogged sewers. This is the #1 operational challenge you are going to face day in and day out.
And the reason they clog is just simple physics. If the water flowing inside the pipe moves too slowly, the solid stuff that's mixed in with it, it just won't stay suspended. It'll settle down to the bottom of the pipe, and over time it just builds and builds until you have a major blockage.
The solution to this is a fantastic engineering principle called self-cleansing velocity. See, it's not just about getting the waste from point A to point B. It's about making sure the flow is moving fast enough to keep itself clean by carrying all those solids along for the ride.
And here it is, the magic number. Your sewer pipes have to be designed with just the right slope and the right diameter to make sure the flow consistently maintains a speed of at least 0.6 meters per second. That's the minimum velocity you need to stop those solids from ever settling down. Okay, another quick field test for you. What's the main purpose of self-cleansing velocity? Is it A, to keep the pipe dry, B, to keep suspended solids from settling and creating clogs, or C, to prevent air from getting into the system? The answer, of course, is B. It is all about keeping everything moving. If you can master this one concept, you've mastered the veins of the city.
And all of this brings us to the final, and I think the most important part of your entire mission. Let's look at the future and see how we complete that circle we talked about right at the beginning.
So get this, as of 2026, a brand new policy is coming into effect. It's called the Circular Mandate. And this is not a guideline. It's a mandatory new blueprint for how water is going to be managed in every single new DDA project from now on.
And here's the absolute heart of that change. We are officially moving from a single pipe system to what's called a dual piping system. One pipe will deliver fresh, drinkable water, just like before. But a second, totally separate line, often called the purple pipe, is going to carry treated, recycled wastewater to be used for things like flushing toilets and watering gardens.
So why does this matter so much? Because we've finally stopped using precious, purified drinking water to just flush our toilets. This is a huge deal. It conserves our fresh water, it reduces the incredible strain on our rivers and groundwater, and it puts our wastewater to good, productive use. This is a fundamental step in building a truly sustainable city for the future.
So, your mission is clear. From the arteries that supply our homes to the veins that drain them away, all the way to the circular systems of the future, you've now got the blueprint for the city's water systems. The only question is, what hidden system will you master next?